Okay, so we're going to start off with the definition of pressure. So do you guys know what pressure is? Under pressure.
It's force over area.
It's force over area. Okay, so pressure is just the force over a given area. Okay, so when we talk about gas pressure, that's basically is going to be the force that's going to be exerted by gas molecules colliding with the surface of objects. So initially, right, or I should say ideally, if these gases are colliding, you're going to have a few of them that are going to collide with each other and they're just going to bounce off under ideal conditions. And then on the walls, they'll bounce off the walls. In actuality, sometimes you'll have gases that will actually collide with each other and then stick together. And that also affects your pressure and those things as well over time. And so we have what we call the ideal situation, and then we have the real situation, right? But a lot of our calculations are based upon that ideal situation. Because it's pretty close, it gives us a ballpark idea, and you don't have to figure out all of these special coefficients and things like that to sit there and do the calculations. But we'll talk about more about that a little bit later in the chapter. Okay, so because we are the US and because we like that empiricalism, in the US we typically use pounds per square inch. Do you guys have cars? Your tires.
Yeah.
What is the pressure of your tires?
35.
Yeah, 30, 34 maybe.
34 what? What are the units?
PSI.
PSI, pounds per square inch, right? So we're familiar with the concept of pressure already, since most of us drive cars and we know that we have to have it at least 30 to 35 PSI. Otherwise, we're wasting gas. So here are some of the other units of pressure. One of them, pascals. A pascal is basically its force over area. So it's 1 Newton over a meter. A kilopascal is going to be equal to 1,000 pascals. An atmosphere is basically the pressure at sea level. So when we do calculations generally around where we're at, in most places where we're at, it's pretty much kind of at sea level. So it's about 1 atmosphere pressure. So 1 atmosphere is equal to 101,325 pascals. And then, of course, the PSI. So 1 atmosphere is equal to 14.7 PSI. A bar, so 1 bar is equal to 100,000 pascals. And a millibar is equal to 1,000. 1 bar is equal to 1,000 millibars. And then we have inches of mercury. So 1 inch of mercury is equal to 3,386 pascals. We have a torr. So 1 torr, or I should say, 1 atmosphere is equal to 760 torrs, or we could say 1 torr is equal to 1 over 760 atmospheres. And millimeters of mercury is equal to 1 torr. Now, there are all of these different units of measurements for pressure because pressure is used through so many different industries: engineering, meteorology, weather, aviation, you name it, pressure is going to be used in most of the industries that we're thinking about. You guys take blood pressure if you're going into the medical field, right? So you need to be familiar with those units, particularly if you're planning to weave in and out of those different fields. Okay, so I have a hard question for you. So let's say I have the elephant, and that elephant is going to weigh about 14,000 pounds. And then we have an ice skater who's going to weigh about 110. Okay. So who's going to apply the most force to the ground? The elephant? Sorry, let me take that question back. Who's going to apply the most pressure to the ground? The elephant or the ice skater?
The elephant?
Everybody agree? Miss Robot, I'm going to say you disagree with her, right? You're taking the opposing opinion. Is that a good translation? Okay, so I'm going to go with my first answer, even though it didn't sound like you said no, but I believe you meant to say yes, right? Okay, what about the rest of you guys? Who thinks it's going to be the elephant? Should we do a poll? Let's do a poll. Oh,
Elephant.
It's the ice skater.
You asked who would put more pressure on the ground, right?
Yep.
Okay. Is this like a trick question?
There's never a trick question.
You have those up your sleeve all the time.
I don't know what you're talking about.
Sorry, it's so dark over here. I'm hosting a movie night at my house.
Ah, and we weren't invited?
It's in my backyard. I have a projector screen back here.
Oh, cool. So we'll just swing by. Okay, that did not work. Oh, here we go. Put your vote in. Man, our class has gotten small.
Dr. Henry?
Yep.
It's like 1/3 of the beginning class, huh?
What was that?
It's like 1/3 of what we started.
Yeah, yeah, it is like 1/3 of what we started. Actually, 1/4, because we started off with, so you guys actually started out with 92 altogether, in both the morning and the evening.
But
Is Monday and Wednesday lecture class bigger than us?
Yeah, they're about 25, 20 to 25. So I guess there's 35 altogether.
Oh, wow.
And that's pretty much what's left. So those who attended lecture are pretty much the only ones that are left. Okay, so let me share my results, and then we'll go over it. Okay, so 5 of you guys said the elephant, 4 of you guys said the ice skater, and 1 of you guys says you. Okay. So pressure per elephant foot, that's going to be equal to the weight. So 14,000 pounds, 1 elephant. 1 elephant has 4 feet. And 1 foot is about 250 inches in area. So for pounds per square inch, the elephant is going to be about 14 psi. The ice skater, sorry, she's 120. So she's going to be 120 pounds per ice skater. The ice skater has 2 blades, and each blade altogether is about 2 inches. So in this case, if you do the math, the ice skater is 30 psi. And you we're assuming that, I don't know whoever you was, but assuming you weighed 120 pounds, about the same weight as the ice skater, but you have big feet. So your feet area is about 30 inches. So then you're going to be about 2 psi. Okay. So clearly the ice skater has a more pressure exerted on the ice than the elephant does, because about the amount of area that's being occupied. Ice skater got this little fine blade, so it's a very fine point where you're putting a whole bunch of pressure. And have you guys anybody ever been ice skating?
Yeah.
Yeah. Have you seen after an ice skater got on there and just did their twirls and everything, what that ice looks like?
Yeah.
And you know why they use the Zamboni, right? So it'll flatten that thing out. So get rid of all the potholes. Okay, so you guys are familiar with some of the units, and let me give you a little bit more. So 1.013 bars is going to be equal to about 1 atmosphere. 1 atmosphere is equal to 760 millimeters of mercury, which also equal to 760 torrs, which also is equal to 14.7 psi. And that's going to equal 101.3 kilopascals. Okay. So here's my first deal for you guys. So if you guys could, I'm going to put you guys in groups, 4 groups. And convert all of these to torrs. So convert the pressure of 29.2 inches of mercury into torrs, atmospheres, pascals, and megabars. I'm sorry, millibars, not megabars. Millibars. Give you what, 2 minutes, 3 minutes? How about 8 minutes?
How about 5?
5? Okay.
I don't know.
Windows open, doors open. Okay, everybody back?
Yeah, we need a little bit more time. But
Need
it's
a little
okay.
more time?
It's okay. It's okay.
Okay, good. So we have 3 groups. Group 1, that's Alexis, Baltazar, Raphael, Selena. Group 2, you guys have this one. That's Nadine, Natalie, and Taylor. And group 3 is Jennifer, Primitivo, and Sean. You guys have the last 2.
Can we get C because that's the one we did?
Can you do C?
Yeah.
Okay, so yes, you guys can do C. And then group 3 will do B and D. Okay. Use my board. Gosh, your guys' handwriting will make me feel so at home.
I couldn't find my stylus. I'm trying to use my trackpad.
Do I have to write out the whole thing? Like,
Yeah.
that's a lot of work. Ah, come on.
Oh, I have to write it all out. You have to write it all out. You don't get special privileges because you're in the dark.
To get out.
Where's your road dog? Where's Nicole, Nadine?
I think she's a little sickies.
Okay.
Actually, she's a lot of sickies. She couldn't even get out of bed.
Porcelain God Sicky?
Huh?
Porcelain God Sicky?
No, I don't think so.
Primitivo, you can't just give me the answer. I don't want just the answer. I want how you got there.
Oh, I answered letter D.
Oh, who did C? Oh, I know who did C. Never mind. Where's the rest of it? Nadine, you asked for C and you just give me the answer. Oh, there we go.
No, I'm writing it. Hold on.
Okay.
Now I messed up. Now I can't fix that. It's supposed to be multiply, then divide. Right here.
Right where?
Right where oh, you can't even see my mouse, huh? We're at the bottom where it's 98871 points. It's multiply. Yeah, times one, and then divide by 1000 PA.
Awesome.
And that equals the 98.87 kPa, which is up here. It's already on there.
Okay.
Thank you.
Okay. Let's see, atmospheres. Good. Are there any questions? Pretty simple. Okay, perfect. We'll keep moving on then. Okay, so to measure pressure, we can use a couple of things. One of the things that is commonly used is a barometer. A barometer basically is a cylinder that has vacuumed and it has mercury in it. And so as the pressure goes up, it pushes mercury up the cylinder. And then you're able to sit there and measure out millimeters of mercury or inches of mercury or whatever unit you want to use in mercury. You can also do the same thing with water, or you can do the same thing with alcohol. Long as you know the density of it, you're able to sit there and calculate the pressure. So the way that you would do that is pressure is going to equal to the height times rho g. Or we could just use millimeters of mercury because there is a direct proportionality. But if we want to calculate the pressure in terms of pascals, we use this equation. Okay, so where H is equal to the height of the fluid, G is the gravitational acceleration due to, gravitational acceleration, and rho is the density. So depending on the density of the fluid, we can sit there and do the calculation. Okay, so calculate the barometric pressure. Show the calculations supporting the claim that atmospheric pressure near sea level corresponds to the pressure exerted by a column of mercury that is about 760 millimeters high. The density of mercury is 13.6 grams per cubic centimeter. The gravitational acceleration is 9.81 meters per second. Okay, so what am I going to do?
Wouldn't you just plug them in?
Just plug them in. Sounds good to me. So we have P equals rho GH. Okay, so a couple things you may need to know. The units of measurement for Pascal. We said it's Newton meter squared. And the Newton is kg. Okay, so if a Newton is equal to kilograms meters per second, so then what are the units that we want to end up with? What are the units that we're given? First off, so for rho, what do we have? We know what G is. What are the units for rho? What is rho? What is rho?
Did you underline it?
No, that's gravitational. That's gravitational acceleration.
Okay.
It's a density.
Rho is density. So what is our density?
13.6
What are the units?
grams.
So if we want our answer to be in pascals, which are going to be in Newton meter, which is going to be kilograms per meters per second, what do I need to do to my density?
Turn to kilograms.
Converted to kilograms.
Converted to kilograms. And
Meters.
converted to cubic meters. Okay, how would I do that?
Multiply by 1 kilogram over 1,000 grams.
1 kilogram over 1,000 grams.
And multiply by 100 centimeter cube over 1 cubic meter.
So what do we get for our density?
$1.36 kilograms per cubic meter.
Okay. Now, what about, see, a gravitational, that's good. So our height. Height is 760 millimeters. So what do I need to do with that? Do I just plug it in?
Do we change it to meters?
Okay. And how would I do that?
It's
Do you
1 meter. Over 1,000 millimeter.
Okay. So then we just plug it all in. Okay, what do you guys get?
It's 1.01 times 10 to the 5 Pascal.
Okay. And how many atmospheres? Atmospheres equals to how much? How many pascals?
One atmosphere equals 101.325.
So pretty darn close. Okay. Questions, concerns, Cash? Okay. Another way of measuring pressure is using a manometer. So a manometer basically is, there's two types. There's a closed-end manometer. Closed-end manometer is basically connected to a vacuum tube. And so in this case, the pressure is just going to be pushing the mercury up the U of the tube. And then so the distance between the levels of mercury is going to give us the height. And so that's how we kind of use that millimeters of mercury, right? Or we could sit there and change it into pascals by using this method right over here, right? Using the height, density, and gravitational acceleration. The other form is a open-ended manometer. So in the case of an open-ended manometer, if the atmospheric pressure is greater than the pressure of the gas, it's going to push the mercury towards the other side of the U, towards the gas. And if that happens, to calculate the pressure for the gas, all you would do is subtract the atmospheric pressure, or you're going to subtract the height times the density and gravity minus the atmospheric pressure. The atmospheric pressure minus the height, the pressure due to the height. I'll give you an example here in a second. So if the gas is greater than the atmospheric pressure, then the difference in height as you push the mercury towards the U is going to be used to add on to the atmospheric pressure. And then that's going to give you the pressure of the gas altogether, because you know it's greater than atmospheric pressure. So it's atmospheric pressure plus that height that you're giving. Okay, so let's do one that's pretty simple. So what is the pressure Okay. Okay, so what is the pressure? That should be if the height is equal to 265 millimeters of mercury towards the gas in an open manometer. Give me the pressure in millimeters of mercury. Any volunteers? Alexis, you've been quiet.
Yeah, I'm just sitting here trying to get the knowledge.
Okay, help me out here.
Because I'm trying to learn myself. I don't know, man. I don't know where to start.
So, what is the pressure if the height is 265 millimeters of mercury towards the gas? So it's going this way. So your height is the difference in height, I should say.
Yeah.
That's 265 millimeters of mercury. So what is your atmospheric pressure in millimeters of mercury?
It's 760.
Yeah. 760.
Okay, so 1 atmosphere is equal to 760. Okay, so then what do I need to do to calculate the pressure of the gas?
Just convert into atmospheres.
So do I have to convert to atmospheres or can I leave it because I want it in millimeters of mercury?
Oh, yeah, that's true.
So it's P of the pressure. And then now we just take in the change, right? So if this is 760 millimeters of mercury, so what do I need to do with this?
We should just subtract it.
I'm just going to subtract it. Piece of cake?
Wow, that was it.
Dr. Henry?
Yep.
Okay.
Are you good?
Yeah.
Okay. You're just checking on me?
Yeah, I was just checking everything.
Okay. So in this context, right? So when we're doing the measurements, it's just we have to make sure that we understand the direction that it's going. So is it going towards the gas or is it going towards the atmosphere? And then we just use that distance or the delta H that we acquire to sit there and figure out whether or not we're going to be adding atmospheric pressure to that distance or that height, or we're going to be subtracting atmosphere from that height, or subtracting that height from 1 atmosphere. Okay, piece of cake, right? Not too hard. So if it's a closed manometer, all we have to do is calculate the height, and that's it. Okay, so the pressure of a sample of gas is measured in a closed manometer as shown to the right above. The liquid in the manometer is mercury. Determine the pressure of the gas in torrs, bars, and pascals. Let's see, Selena, will you do torrs? Jen, will you do pascals? And Natalie, will you do bars?
I'm sorry. So do we just use that 26.4?
Yep, that is the height that you have. And it's in
Okay.
centimeters, not millimeters. So it's
Okay.
centimeters of mercury. Are you guys there? So you're gonna write on my board, Selena?
Yeah.
Dr. Henry?
Yep.
So we have to convert these to millimeters always?
That would be the smartest way of doing it, since we
Okay.
know what millimeters.
Okay.
You don't have to do anything, actually.
I still want to work it out though.
Okay. Piece of cake, Selena?
Yes.
Okay, Natalie? How's it going? Are you there, Natalie? Okay. Raphael, do you want to take our spot?
You're saying Natalie and not Nadine, right? Just making
I
sure.
said Natalie. Yes,
Okay,
not
okay,
Nadine.
okay.
Nadine, you want to take everybody's job, don't you?
Yeah, because I know everything around here.
Dr. Henry?
Yep.
Oh, hold on. I don't know if I can get it. Hold on. Nah, I'm good.
You said you're good?
Yeah, I'm trying, but
Just work it out. Don't worry about it. Just we'll go through it together. So where are we going to start at?
well, I guess we can just start with the millimeters, right? Or no?
You could start with millimeters, or you could take advantage of the fact that Selena are already converted to torrs, right?
Oh, and then we go from torus to atmosphere.
Yep. And then you could go from torrs to atmosphere, and then
Okay.
you could go from atmospheres to Pascal.
Okay, let me see if I got this.
Huh. See. Oh, dude,
It's a divide sign. I don't know if I got the right answer.
So. I would do the calculations for you, but for some reason my phone is not acting right.
I got a. I got this big number, but I'm not sure if it's supposed to be that big.
Okay.
I'll put it, but let me double check it though. Yeah.
Okay. That looks right. So you said 264
All right.
divided by 760 times 101,325.
Hold on. I think I got the sig figs wrong though. I always do. Before you tell me something.
Okay.
Is that cool?
So how many sig figs should you have?
Is it 3 or is it 6?
It's 3. That's right. It's 3.
I don't know why those get me all the time. Okay, it's 3. So
So it'll be like 5 or 35100.
Yeah. Yeah. Okay. Gotcha.
You mean wouldn't it be 35200?
Yeah.
Okay, Jennifer. Can you use the Pascals to go to bars?
Yeah.
No.
I was like, I don't know.
What was that?
I said, heck yeah, but I was just kidding. I don't know.
Yeah, you can.
You can. So let's do it. Gonna write on my board, Jennifer? Is Jennifer ignoring me?
She's shy. I'm pretty sure.
Uh-huh. I'm sure she's shy. Baltazar. Do you want to step in for Jennifer? What is up with the women today? Poor representation. I'm what? One for
We were intimidated.
by who? By gases?
By the bar.
By the bar. Okay, Baltazar, where are you going to start at? Are you going to start with the Pascals?
I don't know how to write on this.
So you go to annotate. If you go up top, you'll have the option. It'll say options and it'll say annotate.
It doesn't say that on mine.
Okay. Do you have a Chromebook?
Yeah, I have an iPhone. I'm on my phone right now.
Oh, if you have your iPhone, it's real easy. You go to the corner and click
Which-
on the
which
corner
one?
and a pen will pop up.
Okay.
Do you see it?
Yeah.
Okay, so now you can write.
Wait, I don't see it. What the heck?
Go in the corner.
Which one?
Okay, Jennifer's gonna write since she's coming back. I just saw her write on my screen. Okay, Jennifer, show me your skills.
She heard you. She's not intimidating anymore.
Are you there, Jennifer?
No, I'm not.
So you're gonna.
I know how to start.
So let's start with the pascals. Let's use this first. So use Raphael's work. So we have 35,200 pascals. There we go. Okay. So how many pascals equal a bar? Anybody know?
100,000.
100,000. Okay, so I could say 1 bar, and we want to get rid of pascals, right, Jennifer?
Yeah.
So I'm going to put a bar on top. We're going to go to the bar on top. And then we'll put our 100,000 pascals on the bottom. $100,000, not 1,000. One more zero, Jen. There we go. Good. And put your units so then we know that we're crossing the mountain.
What the heck?
Whose pen went crazy?
It was mine. I figured it out.
You figured it out. Good job. A little late. Okay, so then
Yeah.
we just divide by 1,000. I mean 100,000. Sorry. What is the answer, Jen?
30. Wait, so we just divide that by that?
Yep. So you just divide this number by this number.
So it's gonna be 35. And then you just add the zeros.
You mean divide zeros. So it goes, and how many zeros do you have? 1, 2, 3, 4, 5, right? So then 1, 2, 3, 4, 5. So wouldn't it be 0.352 bars? Because you're dividing by that number with a whole bunch of zeros, you just go back. So that's 1, 2, 3, 4, 5. Oops. Piece of cake?
Yeah, no.
What do you mean by heck no? You're just dividing by 100,000.
I meant like all of it.
Still a piece of cake. You got this. Just dimensional analysis. Our bread and butter. Okay. Oops. Okay. So let's calculate the let's see, the pressure of a sample of gas is measured at sea level with an open-ended HG manometer as shown above. Determine the pressure of the gas in millimeters of mercury, ATM, and pascals. So let's do Sean. Baltazar, you'll do B. And Primitivo, you'll do C. No, actually, we'll have Taylor. Taylor, you do C.
So since the height's moving towards the open end, I would be adding this to the pressure of atmosphere.
That is correct. Okay, good job. Baltazar, B, can you take what he has for A and convert it?
Yeah.
Okay. And Primitivo, can you take what he has and change it to kilopascals?
Yeah, I got it.
Okay. Does that say 120?
Yeah. Yeah, it's 120 kilopascal.
Okay. With a decimal point after the, right there. So we keep our 3 sig figs, right? Okay, piece of cake. Just conversions.
Wait, because it's open end, is that when we use 760 millimeter mercury?
Yeah, because we have to add it to it. That's correct, because it's open-ended. And the fact that it's going in the other direction, that means that the gas is going to be greater than atmospheric pressure. So that means you're adding the atmospheric pressure, which is 760 millimeters of mercury, to
Okay.
the height that it went up.
Okay,
So-
okay.
So if it was the other way around, if it was going towards the gas, would it be
Yep.
subtract?
Yep, so you go 760 minus whatever the height would be.
Okay.
Okay,
Gotcha.
piece of cake.
Yep.
Okay, here. Oops. Okay, I have one more. Okay, let's see. So here we have the pressure of a sample of gas is measured at sea level with an open-ended mercury manometer, as shown to the right. Determine the pressure level. Determine the pressure of the gas in millimeters of mercury, ATM, and kilopascals. Raphael, do you want to take the first one? Selena, take the second one, and Alexis, take the third one.
She's my sister. Oh,
Okay. Good job. Good job. Questions, concerns, Cash?